Chapter 5 has to do with the unit circle, angles, trig functions, how everything is related. So to get started, we're just going to start with 5.1, which is a basic intro to angles and their measure. So an angle is determined by rotating a ray around its endpoint. The starting ray is called the initial side of the angle, and the position after rotation is called the terminal side of the angle. Think about this. Initial, the beginning, the start. We talked about initial time, what's the initial amount of mass when we're talking about exponential decay or exponential growth. Initial meaning start. The initials of your name, or for your name, they're the first letters of your name. Terminal, meaning the end, to terminate something, to finish it. So the terminal side of the angle is the end. When it's in standard position, the initial side lines up with the x-axis. Positive angles are always rotated counterclockwise, and negative angles are always rotated clockwise. So if we're looking on a graph here, and we had an angle that lined up, standard position, this would be our initial side. Here would be our angle, which we denote with theta. It's a 0 with a little bar through the middle. And then this part here would be our terminal side. So if you need to add that to your notes, this, a 0 with a thing, this is called theta. It's a Greek letter and it represents an angle. That's all. Just like we use x or y, we're just going to use theta. So the measure of an angle is the amount of rotation from the initial side to the terminal side. The most common unit you've probably heard already is degrees. We're going to talk about different angles, different ways to measure them, and different units and how to convert between them all. There are several common angles. Some of them you probably already know, if not all of them. The first is an acute angle, which measures between 0 and 90 degrees. The next is a right angle, which measures 90 degrees. Obtuse, meaning greater than 90 but less than 180. A straight angle is 180, and then a full angle is 360 degrees. So it just looks like a line here, but it's actually that the angle has rotated one full rotation around. So the terminal and the initial are the same ray. They're on the same ray. So angles are coterminal when they have the same initial and terminal rays. An example of this, 9 o'clock a.m. and 9 o'clock p.m. are coterminal angles. You don't know the difference by looking at a clock if it's set at 9 a.m. or 9 p.m., except for your experience during the day and your experience in the real world. Otherwise, 9 o'clock a.m. and 9 o'clock p.m. look exactly the same on a clock. It's just one extra rotation around. So you can find these angles by adding or subtracting 360 degrees. So that would be like me saying this angle right here, let me get another color, which we'll call theta, and then an angle that just went one extra rotation, so started here, went all the way around, and then ended here, we'll call this one beta. Those are coterminal angles. They look the same. Minus that extra rotation, their start and end are actually the same. It's just one more rotation all the way around. So to find coterminal angles, this one asks for one positive and one negative. Again, you add or subtract 360. That's all that it is. It's one more rotation around. So to find a coterminal, I'm going to subtract 360 here and get 30 degrees. So 30 degrees and 390 degrees are coterminal angles. If I set an angle at 30 and do one more full rotation around my unit circle, I'll get 390. There's a positive one, so this is 1. And actually, if I just subtract 360 from here, I'll get negative 330 degrees, meaning these angles are all coterminal. 390 degrees is the same as 30, is the same as negative 330. It's just a matter of an extra rotation around your unit circle. So negative 120 degrees, what are two coterminal angles you would have for negative 120 degrees? Okay, hopefully you ended up with, by adding 360 degrees, you got 240 degrees, and by subtracting 360 degrees, you got negative 480 degrees. So next up are complementary and supplementary angles. I'm assuming most of you have seen this before. Complementary angles are positive angles that add up to 90 degrees, and supplementary angles are angles that add up to 180 degrees. A way to remember this, complementary, we're talking about a right angle, which sits in the corner. Think corner, complementary, the C's. 180, we're talking about a straight angle. Think straight, think supplementary. So S and S versus this one has a corner, and we're thinking complementary. So a way to find these is to subtract from 90 or 180, whatever they're asking for. So for complementary angles, I would say, well, the positive angle that's going to add to 72 to get 90, I would have to do 90 equals 72 plus x. so x is equal to 18 degrees. And supplementary, I'm trying to get to 180, so I would do 72 plus, we'll call it y in this case, and I'll end up with y is equal to 108 degrees. For 148 degrees, for our complementary, we would say 90 is equal to 148 plus x. And actually, this does not have a complement, no complement. And the reason is that by definition, they must be positive angles that add up to 90. So the fact that there's no positive angle I can add to 148 to get me 90 tells me there is no complement. And then the supplement would just be 180 minus 148. And I would end up 32 degrees. Another way to measure angles is in radians. So just think of it as if you measure something miles versus kilometers. It's the same thing, you're just talking about a different unit. So in the end, it's the same value, we're just measuring in different units. So 1 radian is the measure of a central angle theta that intercepts the arc S, equal in length to the radius of the circle. So S is equal to theta, the measure of the angle, times r. So let me explain here. We have a radius in our circle, and we know that if I'm truly in the center, then the radius here is also the same as the radius here. And if this is theta, this is S. So theta is equal to, if I was going to convert this, theta is equal to S divided by R. So radian measure, that's where it comes from, 1 radian. And we're going to talk about radians versus degrees and how to convert in just a second. 2 pi radians is equal to 1 full rotation around the circle. When we're using pi and we're using radians, you're going to leave as pi. Don't try and convert, don't try and plug anything in, you're just going to leave it as pi, which is a little uncomfortable for people in the beginning because in the past you've always probably plugged it into your calculator. When we're talking about radians, we leave it in terms of pi. When you're talking about degrees, that's where you would go to your calculator and press the pi button because we don't want to use, pi is irrational, so it's not going to be a nice neat number at any point. When you're converting from degrees to radians, think about all your other conversions. If you have degrees, what you're going to end up doing is multiplying by 1 radian, 1 pi radian, over 180 degrees. So 1 pi radian is equal to 180 degrees. If 2 pi radians is the whole circle, well, we know a whole circle is 360, so half of that must be 180. And in the end, I'm going to have theta pi radians, because what will happen, What will happen is my units of measurement of degrees will cancel, and I'll just be left with theta, which would have been up here, and then pi on the end. So if I'm going the other way, from radians to degrees, I'd multiply by pi radians by, flip it over, so 180 degrees. Whatever I want to be left with is what I want to put on the top over pi radians. But this is the conversion piece that you want to know, that 180 degrees is equal to 1 pi radian and the other way around. That's your conversion factor. Because in the end, radians will cancel, and I'll just be left with my angle measure in terms of degrees. When no angle measure is given, assume that radian was used. So if you don't see a degree sign, you need to assume they're talking about radian. So that's key. All right, so if I'm going to convert some angles, what I need to do is keep in mind that conversion factor. So I have 135 degrees that I'm trying to convert to radians. So 135 degrees, if I put that over 1, I'm going to multiply by, I want to be left with radians, so I put radians on the top. Pi radians is equal to 180 degrees, which I can also just write as this, if that's easier for you. And I'm going to multiply through. Remember, for fractions, multiply the numerators, multiply the denominators, and then reduce. So what ends up happening here is I get 135 pi all over 180. The degrees end up canceling, and then I'm going to reduce this. I'm going to reduce 135 by 180, and I end up with 3 pi over 4 radians. So now to go the other way, I have an angle in radians, I want to go to degrees. All I do is flip that conversion factor of 180 degrees as pi radians. So I have radians, I'm going to multiply by, I'm going to keep what I want on the top. So I want to end up with degrees, so 180 degrees on the top, and then I'll put pi radians on the bottom. And when I multiply through, first of all, the radians cancel, and then also I have a pi on the top and a pi on the bottom. Those both cancel. So really what I have here is negative 180 degrees over 2, which reduces to negative 90 degrees. We're going to get into, as you can see, there's more ahead, finding coterminal angles using radian and degree measure, as well as finding complementary, supplementary, and then linear and angular speed. We're going to do that in class, and we're going to use our unit circle for that. It makes things a lot easier if you can visualize at the same time, but I just wanted to take a minute to introduce this idea of degrees and radians and talk about conversion, as well as review quickly complementary, supplementary, and then your basic angles.